Hello everyone, so today we have an MCAT typical torque question right here. So let's see how we do it. So if you want to take a minute, pause the video and do the question, then come back. Okay, so on pause. So in the illustration below we have a rod that is 1 meter long. Okay, that's very important, so that means that from here to here, that is 1 meter. And has a mass of 200 grams. So I'm just going to convert this. So I'm going to say mass equals 0.200 kgs. That's what we usually work with. Okay, the pivot is 20 centimeters to the left of the center of the rod. So okay, so I can detect this center, and then it says to the left of the center. So it's from here, that's the pivot point. This is pivot point number 1, I'm going to call it. And so from here to this point, this is 20 centimeters. I'm just going to convert this to 0.2 meters, okay, keeping the significant figures. After that, we're going to go, okay, and so the object on the left end of the rod has a mass of 1 kg, so this right here is going to be 1 kg, and the object on the right has a mass of here, so I'm going to write this mass as equals 0.500 kgs. This is just given the question, so we're asked what is the net torque on the rod. So ultimately, what is the net torque? I'm going to use this definition as torque equals to the force multiplied by the distance that is perpendicular to that force. Okay, so let's apply the forces that are acting on the rod itself. So on the rod only. Okay, so the first one, well, I can see this one coming down, so that's the FG1, let's call it. So that's acting on the rod on this direction. Next, we have an applied force going upwards from here, from the rod. We have then this FG, I'm gonna call this FG2, and then we have this FG3 going downwards. Okay, however, because I said that we're gonna use this as the pivot point, I don't really care about this because the distance is 0. So here in FG1, well, this is my pivot, so that's gonna be my distance 1. Well, for FG2, well, from here to here, that's gonna be my distance 2. And for FG3, it's gonna be from this here to the action line of action, which is distance 3. Okay, now I have to answer the question. Well, what's my pivot equals to? So I'm gonna be concerned with the net torque, so I'm not gonna put in 0 in here because we don't know if it's stable or not. Okay, after, so it says net torque, so I suspect it's not gonna be 0. So after that, what we're gonna do is we have to figure the directions. So we're gonna say, okay, so anything going this direction is gonna be positive, going that direction is gonna be negative. Okay, so what we do is, okay, so going clockwise is negative, going anti-clockwise is gonna be positive, counterclockwise. So what do we do here? Okay, so we start with the first force here, Fg1 multiplied by d1. Okay, so that's going down, so this is positive. And then, okay, I'm going to subtract that from, so this is, we said, is going to be 0 because the distance is 0, so it doesn't really matter. Here we have Fg2, that's negative, because if we left it, the whole thing is going to go downwards. So just look at the individual forces and where do they go, then multiply by d2, and then you're going to subtract that for Fg3 and d3, because if you leave the force, it's going to go downwards. And so we have here the torque is going to equal to, well, what is Fg1? So we know that Fg is equal to m times g. So for any value of g, I'm going to use 9.81 meters per second squared. That's the acceleration due to gravity. You could use 9.8 and still get similar answers. So here, okay, so Fg1, which is going to be, so 1 times 9.81, which is 9.81. Okay, I'm not going to write the units because I don't have really much space, but you know that torque is n times meters, newtons times meters. Okay, so the distance is right here. So how can I figure this distance out? Well, I know the whole thing is 1 meter. If I took the center, that's going to be 0.5, and I subtracted 0.2, that's going to be 0.3. So my distance is 0.3. Subtracting that, okay, so Fg2 is the center. We're given that it is this mass, 0.200, so I'm just going to use my calculator, multiply 0.200, multiply 9.81, and that should give me an answer of 1.962 multiplied by d2. Well, it's fairly simple here. So if you want to check, it's 0.2, but if you want to check, okay, so we take the half, and we know that this is equal to 0.3. We subtract that, and then we're left with 0.2, so this is going to be 0.20 right here. Okay, and then you have to subtract that from Fg3. So Fg3, we know it's 0.500 multiplied by 9.81. That should give you an answer of 4.905. Okay, and the answer, because it's going this direction, multiplied by the distance, which is from this distance, from this side to this side right here. Okay, so I know if I took, so I know this is 0.3, the whole thing is 1 minus 0.3 is 0.70. Okay, so here I'm just going to put in everything in my calculator and multiply. So 9.81 multiplied by 0.30, that should give me an answer of 2.943 minus, I have 1.962 multiplied 0.20, that should give me an answer of 0.3924, and then minus 4.905 multiplied by 0.70, and that should equal to 3.4335. And then we subtract all of that, so then we're left with the net torque. So the net torque is going to equal, so 2.943 minus 0.3924. So from here you suspect it's going to be a negative number. Okay, so it's going to then subtract 3.4335. And so we're left with negative 0.8829. Okay, so here it's very important to look at what you've identified as negative and positive. If you look right here, on this side, right here, so if you look right here, we've said that going this direction, which is clockwise, is going to be negative. Going counterclockwise is positive. Okay, so we got a negative answer. And we look at here, well, we have 0.9, which is very similar to this, and it's clockwise because we identified negative as being clockwise. So here is going to be your answer. The answer for this question is A. Okay, so I hope this was helpful. Thanks so much and have a good day.